Imagine for a moment that you could tweak the fundamental controls of the universe, as if you were a cosmic DJ adjusting the knobs on an infinite saddleboard. What if I told you there are specific numbers, universal constants, that if altered by just a microscopic fraction, you simply wouldn't exist? In fact, nothing we know would exist. No stars, no planets, no atoms. The universe would be a completely alien and likely empty place. Today, we're going to explore the fundamental constants of nature. These mysterious numbers that seem to have been fine-tuned with an almost impossible precision to allow life and everything we know to exist. We'll discover what would happen if the speed of light were different, if Planck's constant changed its value, or if the fine structure constant were adjusted. And in the end, I'll reveal a disturbing discovery. Some scientists are finding evidence that these constants may not be so constant after all. Welcome, cosmic explorers, to the Cosmic Frontiers channel. We're on a fascinating journey towards 1,000 subscribers, unraveling the universe's greatest mysteries together. Let's start with a question that might seem simple, but will shake your perception of reality. Why does the universe work? I'm not talking about the Big Bang or the evolution of galaxies. I'm talking about something much deeper and more mysterious. Why do atoms hold together? Why does light travel at the speed it does? Why do the fundamental forces have exactly the intensity they have? The answer lies in the fundamental constants of nature. Think of them as the universe's basic settings, the parameters that define how everything works. They are pure numbers, without units, that appear in the most fundamental equations of physics. And here's the truly astounding aspect. If any one of these constants were slightly different, the universe would be a radically different place, probably incapable of sustaining any form of complexity, much less life. Imagine you're building a house, but instead of using bricks and cement, you're using the very laws of physics. The fundamental constants would be like the technical specifications of that construction. If the strength of the materials were slightly different, if gravity were a little stronger or weaker, if electromagnetic forces had a different intensity, your cosmic house would simply collapse before it was even built. Let's meet the protagonists of this cosmic story. First, we have the speed of light in a vacuum, represented by the letter c. It's not just the maximum speed of the universe, it's literally the fabric of space-time. Einstein showed us that space and time are intertwined, and the speed of light is the constant that defines this relationship. Currently, it's approximately 300 million meters per second. Then we have Planck's constant, represented by the letter h. This is the constant that governs the quantum world, defining the smallest possible unit of action in the universe. It's as if the universe were pixelated at its smallest scale, and Planck's constant defines the size of these cosmic pixels. And then we have one of the most mysterious, the fine structure constant, represented by the Greek letter alpha. This constant defines the strength of the electromagnetic interaction. It's a pure number, without units, approximately 1 divided by 137. Physicist Richard Feynman once said that all physicists should hang a sign in their offices with this number and worry about it. Now, let's do a disturbing thought experiment. Imagine you have the power to alter these constants. What would happen if you tweaked the fundamental controls of the universe? Let's start with the speed of light. If you significantly increased the speed of light, nuclear reactions in stars would happen much more rapidly. Stars would burn through their nuclear fuel in millions of years instead of billions. There wouldn't be enough time for planets to form, much less for life to evolve. On the other hand, if you drastically decreased the speed of light, the universe would be a much slower and colder place. Stars would take much longer to form, and the radiation they emit would be far less efficient. But here's the most disturbing aspect. Altering the speed of light wouldn't just change the speed of things. Remember, E equals mc. Energy and mass are related by the speed of light squared. If c were different, the very relationship between energy and mass would be different. Atoms might not be able to form, or they might be completely unstable. Now, let's mess with Planck's constant. This constant defines the scale at which quantum effects become important. If you significantly increased Planck's constant, quantum effects would become visible in the macroscopic world. Imagine a world where you could literally walk through walls by quantum tunneling, where objects could be in two places at once. It would be an Alice in Wonderland universe, but probably incompatible with any form of organized life. If you decreased Planck's constant, quantum effects would become even more microscopic. But here's the problem. Many fundamental life processes depend on quantum effects. Photosynthesis, for example, uses quantum effects to transfer energy with almost perfect efficiency. Without these effects, plants wouldn't be able to capture solar energy efficiently, and the entire food chain would collapse. But it's when we mess with the fine structure constant that things get truly scary. This constant defines the strength of the electromagnetic interaction. If you increased it, making the electromagnetic force stronger, electrons would be more tightly bound to atomic nuclei. This would make chemical reactions much more difficult. In fact, if the fine structure constant were just 4% larger, it would be impossible to form carbon in stars. Without carbon, there would be no organic chemistry, no life as we know it. On the other hand, if you decreased the fine structure constant, making the electromagnetic force weaker, atoms would become much larger and less stable. The complex molecules necessary for life simply wouldn't be able to form. Think of it like trying to tune a cosmic piano. Each fundamental constant is like a string on that piano. If any one of them is slightly out of tune, the cosmic symphony becomes a cacophonous noise. But when all are perfectly tuned, as they are in our universe, they create a harmony that allows galaxies, stars, planets, and life to exist. This apparent precision of the fundamental constants has led some scientists to propose what is known as the anthropic principle. The idea is that we observe these constants with these specific values, because we are observers who can only exist in a universe where these constants allow our existence. It's like asking why you always find your keys in the last place you look. It's not because they're always there, it's because you stop looking when you find them. But this raises an even deeper question. Were these constants tuned by some process, or are there multiple universes with different values of constants, and we simply happen to be in the universe where they allow our existence? Some physicists, like Max Tegmark and Brian Greene, propose the existence of a multiverse, an infinite collection of universes, each with different values for the fundamental constants. In most of these universes, the constants would be incompatible with the existence of complex structures. But in a few like ours, the constants would be tuned to allow the existence of galaxies, stars, planets, and life. It's an idea that is both humbling and inspiring. Humbling because it suggests that our universe may be just one among infinite others, with nothing special about it. Inspiring because it suggests that the existence of life and consciousness may be an inevitable consequence of the vastness of the multiverse. But here's where the story gets even more intriguing. For decades, we assumed that these constants were exactly that, constants, fixed numbers that never changed. But recent research is questioning this fundamental assumption. In 1999, physicist John Webb and his team made a disturbing discovery. They were studying the light from distant quasars, extremely bright objects in the early universe. When this light passes through clouds of gas in space, certain wavelengths are absorbed, creating a characteristic pattern known as absorption lines. But Webb discovered something unexpected. The absorption lines from the light of very distant quasars were slightly different from what they should be if the fine structure constant had always had the same value. The data suggested that, billions of years ago, the fine structure constant was slightly smaller than it is today. Imagine discovering that the speed limit on a road changed over time, but no one told you. That's roughly what Webb was suggesting about one of the most fundamental laws of the universe. Initially, many scientists were skeptical. The idea that a fundamental constant could vary over time was too revolutionary to be easily accepted. But subsequent studies, using increasingly sophisticated telescopes, continued to find evidence that the fine structure constant may have changed throughout cosmic history. Other scientists began to look for variations in other fundamental constants. Some studies suggested that the ratio between the proton mass and the electron mass may have changed slightly over billions of years. Others investigated whether Newton's gravitational constant might be slowly changing. These researchers used some of the most sophisticated techniques in modern astronomy. Scientists analyzed the light from extremely distant objects, looking back in cosmic time. They studied the precise frequencies of radiation emitted by different elements, looking for small changes that could indicate that the fundamental constants were different in the past. It's like being a cosmic detective, looking for clues left by light that traveled for billions of years to reach us. Each photon carries information about the conditions of the universe when it was emitted, including the values of the fundamental constants at that time. But why would the fundamental constants change? Some theories suggest that they may be connected to quantum fields that permeate all of space. Just as the Higgs field gives mass to particles, there may be other fields that determine the values of the fundamental constants, and these fields may be slowly evolving over cosmic time. Other theories propose that we live in a universe of extra dimensions, and that the constants we observe are actually projections of more fundamental quantities in these extra dimensions. If the geometry of these extra dimensions is changing, this could cause apparent changes in the fundamental constants. It's important to note that, if these changes are really happening, they are extremely small. We're talking about variations of 1 part in a million or less over billions of years. To put this in perspective, it's like the speed limit on a road changing by 1 millimeter per hour over the entire history of humanity. But even such small changes could have profound consequences for our understanding of the universe. If the fundamental constants are not really constant, it means that the laws of physics may be evolving. Today's universe may operate under slightly different rules than the rules that governed the early universe. This also has implications for the future. If the fundamental constants are changing, what will the universe be like billions of years from now? Will the changes be so small that they won't make a difference, or will they eventually accumulate to create a fundamentally different universe? Some scientists speculate that, if the fine structure constant continues to change in the direction some studies suggest, eventually chemistry may become impossible. Atoms may become unstable, molecules may not be able to form. It would be the end, not only of life, but of all complexity in the universe. Others are more optimistic, suggesting that the changes may be cyclical, or that they may stabilize at new values that still allow for the existence of complex structures. The truth is, we still don't know for sure if the fundamental constants are really changing. The evidence is intriguing, but not conclusive. Different research groups sometimes reach contradictory conclusions, and the proposed changes are at the limit of what our instruments can detect. But the very possibility that the fundamental constants might vary is forcing physicists to rethink some of their most basic assumptions about the nature of reality. If the constants are not constant, what else that we assume to be fixed might be changing? This research is also driving the development of new technologies to detect such small changes in the fundamental constants. Scientists need extremely precise atomic clocks, incredibly sensitive spectrometers, and telescopes capable of measuring light frequencies with unprecedented accuracy. Some of these technological advancements are finding applications in other areas. Ultra-precise atomic clocks are essential for the functioning of GPS. Sensitive spectrometers are used in the detection of exoplanets. The search for variations in the fundamental constants is, inadvertently, driving innovations that benefit all of society. So, where does this leave us? We live in a universe where the fundamental rules may be slowly changing, in ways we can barely detect. It's an idea that is both disturbing and fascinating. Disturbing because it questions our assumption that the laws of physics are eternal and immutable. Fascinating because it suggests that the universe may be even more dynamic and evolutionary than we imagined. Recapping our cosmic journey today, we discovered that the fundamental constants are like the controls of a cosmic DJ, fine-tuned with almost impossible precision to allow the existence of everything we know. We explored how small changes in these constants would make the universe a radically different and probably uninhabitable place. And we revealed the disturbing possibility that these constants may not be so constant after all, slowly changing throughout cosmic history. This leads us to a profound reflection on our place in the universe. Are we products of an incredible cosmic coincidence, where the fundamental constants happen to have exactly the right values to allow our existence? Or are we part of a vast multiverse where our existence is a statistical inevitability? And if the constants are changing, are we witnesses to an evolving universe, where the very rules of reality are transforming? Perhaps the most honest answer is that we still don't know, and perhaps that uncertainty is the most beautiful thing about science. Every discovery opens new questions, every answer reveals new mysteries. We are on a journey of discovery that may never end, and that is extraordinary. Cosmic explorers, here's my question for you. If you could alter one fundamental constant of the universe, which would it be and why? Leave your answers in the comments. I love reading your reflections and theories. And since we're talking about the fundamental mysteries of the universe, what cosmic enigma do you want me to talk about in the next video? Black holes, dark energy, the origin of life. Leave your suggestions in the comments. We're on an incredible journey towards 1,000 cosmic explorers. If this video expanded your perspective on the fundamental nature of reality, join our crew by clicking subscribe. Like this video if it sparked your curiosity about the universe's secret controls, and share it with someone who is also fascinated by the mysteries of existence. In the next video, we'll explore another enigma that challenges our understanding of reality. Until then, keep looking at the stars and questioning everything. The universe is full of secrets waiting to be discovered, and we are just beginning to scratch the surface of this infinite cosmic adventure.